The James Webb Telescope discovered the loss of 900 trillion stars. Neil deGrasse Tyson explains the cosmic mystery. Tyson, a leading astronomer, helps us understand the universe. He explores the spectral, temporal, and spatial dispersion of these fading stars. What causes such a massive cosmic event? Were star systems born or died? Tyson will reveal the secrets of space, leaving us astonished and wanting more. Hubble, the other famous American space telescope, saw a star disappear in 1993 in this story's world. The disappearance of 900 trillion stars has been noticed by scientists. The James Webb Space Telescope, a revolutionary observatory designed to reveal the mysteries of the cosmos, has made a startling discovery. A staggering number of stars have mysteriously vanished into space, as spotted by the telescope. This astounding discovery indicates that a staggering 900 trillion stars have vanished from the observable universe. This finding has far-reaching consequences and complicates our knowledge of the dynamic world. While the birth and death of stars is a constant process, the sheer size and scope of this disappearance has stunned scientists. Many mysteries surround the potential causes and cosmic forces at play in such an occurrence. As astronomers explore deeper into this phenomenon, they aim to learn more about the history of galaxies and the complex workings of the cosmos, as well as uncover the fate of these disappeared stars. The James Webb Space Telescope remains crucial to our ability to understand the cosmos and to explore new areas of discovery. The larger mirror size of a telescope plays an important part in improving its observational capabilities. This enables the telescope to capture more light and attain higher precision while examining celestial objects that are fainter and more distant. When a telescope's mirror is larger, it is able to gather a greater quantity of incoming light. This directly correlates to an enhanced capability to discover and analyze fainter objects in the cosmos. When watching faraway galaxies, nebulae, and other celestial beings that emit dim light, it is very helpful to have a larger mirror since it increases the amount of light that can be gathered by the instrument. Astronomers are able to go further into space and uncover the mysteries that lie buried inside the expanse of the universe as a result of this. In addition, the larger mirror size helps achieve a greater resolution, which in turn reveals finer details in the objects that are being watched. This provides a better degree of precision for scientists when they investigate phenomena such as exoplanets and gravitational lensing, as well as allowing them to recognize intricate structures and investigate the composition of faraway stars. The cutting-edge scientific device is equipped with incredible infrared capabilities, giving it the extraordinary potential to descend into the depths of cosmic dust and solve the mysteries of celestial objects concealed within interstellar clouds. This cutting-edge technology allows researchers to peek into the center of cosmic phenomena, revealing the intricacies of star formation, planetary evolution, and galaxy dynamics. This is made possible by avoiding the obstruction posed by ordinary optical wavelengths, which are the industry standard. This game-changing instrument overcomes the constraints imposed by cosmic dust, which frequently obscures and distorts the image of distant celestial bodies. It does this by harnessing the strength of infrared light, which allows it to successfully penetrate these interstellar clouds. As a result, it offers insights on the formation, development, and interactions of stars, planets, and galaxies that have never been seen before. Our comprehension of the incomparably enormous cosmos is vastly improved as a result of the availability of such an invaluable skill, which also helps to illuminate the processes that underpin the expansion of the universe. The infrared prowess of this instrument opens up a new area in astronomical research, widening the horizons of human knowledge. This device can be used to investigate protostars hidden within dense molecular clouds, discover the mysteries of exoplanets, and explore the birth of galaxies. In our continuous endeavors to fathom the tremendousness of the universe, we have found that the telescope is a very accommodating instrument. Its abilities go past the perception of far-off stars and worlds. It likewise can explore the airs of exoplanets, which would open up new pathways for research. Its abilities reach out past the perception of far-off stars and worlds. The refined spectroscopic capacities of the telescope empower it to explore the makeup of the airs of extrasolar planets to search for signs kinds of conditions ideal for the presence of life. One of the main objectives is to lay out whether there is any hint of water, which is a fundamental part of life as far as we might be concerned. Likewise, the telescope looks for the presence of natural synthetic substances, which are basic parts in the arrangement of living things. Researchers can learn fundamental data about the expected tenability of exoplanets by inspecting the airs of those universes. There is a higher possibility of finding livable exoplanets past our nearby planet group on the off chance that there is water and natural mixtures present. This will expand the possibilities of finding planets with environments that are appropriate forever. Not only does the telescope increase our knowledge of exoplanets through these in-depth examinations, but it also takes us closer to finding the answer to one of humanity's most fundamental questions: whether or not we are the only intelligent life in the universe. An amazing astronomical observatory, the James Webb Space Telescope, or JWST, is located at the second Lagrange point, or L2, of the Earth-Sun system. L2 is a one-of-a-kind position that is approximately 1.5 kilometers away from Earth. It is here that the gravitational pull of both the Sun and the Earth are equalized, which results in the telescope being placed in a stable orbit. Because of its advantageous position, the James Webb Space Telescope can remain relatively constant in relation to the Earth, which makes it an excellent vantage point from which to study the cosmos. L2's capacity to offer great protection against the light and heat of the sun is undeniably one of its most significant features. The revolutionary sun shield, which consists of 5 layers and is roughly the size of a tennis court, is an essential component in the telescope's design, since it helps to shield the sensitive equipment from harmful radiation. The JWST is able to efficiently block out the tremendous heat and light from the sun by deploying its sun shield. It helps the observatory to maintain a cold and stable environment, which is important for capturing faint signals from faraway cosmic objects. The James Webb Space Telescope offers up new frontiers in space exploration by capitalizing on the stability and shielding afforded by the second Lagrange point. This enables scientists to peek deeper into the cosmos and uncover the mysteries of our universe. A celestial refuge that is recognized for its continuous observations and limitless possibilities may be found in the depths of space, far beyond the confines of the atmosphere that surrounds Earth. This is the ideal vantage point for revealing the mysteries of the cosmos. This remarkable location allows for continuous and unbroken observations, free from the restrictions imposed by the atmosphere of Earth and the limitations imposed by daylight. This heavenly observatory is free from the disruptions that are created by atmospheric turbulence and light pollution, and as a result, it provides a vision of the cosmos that is untouched by the veil that the Earth casts over it. Astronomers who are stationed at this vantage point have the distinct advantage of being able to observe the wondrous phenomena that take place in the vastness of space without the hindrance of the atmosphere. As the observatory transforms into a portal to the wondrous phenomena of the cosmos, the stars, galaxies, and nebulae in the cosmos display their real splendor. This extraordinary position enables astronomers to continually investigate and photograph celestial wonders, since it is always dark there and there is a direct line of sight to the object of their study. The continuous observations that are made from this vantage point in space offer the potential to solve some of the universe's most perplexing puzzles, which would push the limits of human understanding further than they have ever been pushed before. In an effort to better understand the cosmos, astronomers are carefully analyzing the spectral properties, temporal trends, and spatial distribution of fated stars. By examining these factors, scientists hope to learn more about the cosmological setting in which this phenomena occurred. The composition, temperature, and other physical features of stars can be deduced from their spectra. Astronomers can determine if there were any remarkable chemical or elemental changes in the spectra of disappearing stars. By analyzing temporal trends, astronomers can learn more about the length and frequency of these occurrences. This information can be used to test hypotheses regarding the origins of the phenomenon, which may have to do with stellar evolution, catastrophic occurrences, or some other astrophysical phenomenon. Additionally, astronomers are able to determine if there are any clustering or alignment tendencies in the vanishing stars by analyzing their spatial distribution. By carefully examining these variables, astronomers aim to better comprehend the mysterious nature of vanishing stars and, by extension, the cosmos itself. We think you'll find this video about the mysterious demise of stars interesting, and we'd appreciate it if you'd subscribe to our channel.